Dear viewers, today's lecture is for class 12 mathematics and the topic is inverse trigonometric functions. Let me briefly explain here a function. As you know that a function is a special type of relation in which no two ordered pairs have the same first entry. Let's have a clear idea for this function by means of this arrow diagram. Let me consider here a set A with the elements x1, x2, x3, another set B with the elements y1, y2. Let me write here the association like x1 is associated to y1, x2 is associated to y2 and x3 is associated to y2. And writing the relation R is equal to set of these ordered pairs x1, y1. Another ordered pair x2, y2. Third ordered pair is x3, y2. Look at the ordered pairs of this relation. None of the two ordered pairs have the same first entry. So clearly we can say that this relation, it is a function. Actually, we are going to discuss inverse trigonometric functions. For this, let me write here trigonometric ratios. You know that these trigonometric ratios behave like functions. Actually, these trigonometric ratios are functions, trigonometric functions. So, let us discuss the domain, and these trigonometric functions are sine, cosine function, then we have tangent function, and accordingly they are reciprocals. You can write here cosec, then sec and cot. The domain of this sine function is set of all reals. As you know that this sine function is defined for all real values of the angle involved. So we can say that the domain of this function is set of all reals. And the range of this function is the closed interval -1, 1. Similarly, the domain of this cosine function is set of all reals and the range is the closed interval -1, 1. Now, अब हम इसका डिस्कस करेंगे. What is the domain of this tangent function? The domain of tangent function is set of all reals except odd multiples of pi by 2. Odd multiples of pi by 2 and this n belongs to set of integers, and the range of this tangent function is set of all reals. Now the question is, why we say that the domain of this tangent function is all reals except odd multiples of pi by 2. Let me write here a tangent function tan theta. We will discuss why we restrict these numbers from the domain of this tangent function. You know that this tan theta, it can be written as sin theta over cos theta. And let us say that theta is equal to 90 degree, pi by 2. So therefore, we can write tan pi by 2, it can be written as sin pi by 2, I am replacing this theta by pi by 2. Similarly, cos of pi by 2. You know that sin 90 is equal to 1 and cos 90 is 0. That means we can say this function is not defined at theta equal to pi by 2. Similarly, when you use theta equal to 3 pi by 2, again the function is not defined. When you use theta equal to 5 pi by 2, the function is not defined. Similarly, for all odd multiples of pi by 2, tan theta is not defined. Similarly, you can determine the domain of this the reciprocal of the sine function, that is cosec. Similarly, sec and cot, जो आपने already पढ़ा है क्लास 11 में, आपने already पढ़ा होगा ये. What is the domain of cosec, then sec, then cot function? Now, as you are already aware of the fact that a function is said to be invertible if it is bijective, that means it should be 1, 1 and onto function. Now let's have a look on the graph of the sine function. it is 0. This is quadrant number 1, pi by 2. It is pi. Then we have 3 pi by 2. This is 2 pi. These are the negative angles, minus pi by 2. This is minus pi, and so on. Draw the graph of this sine function. You know this, the curve will be like this. The highest value is 1. Then it decreases from 1 to 0 at pi. Further decreases from 0 to minus 1. And in fourth quadrant, it increases from minus 1 to 0. Similarly, if the angle is negative, graph will be like this. Right? Now let us discuss whether is it possible to determine the inverse of a sine function. Look at the graph of this function, or simply we can draw here an arrow diagram to check whether this sine function is 1, 1 or not. Let us say it is set x and set y. Let me start with these angles, minus pi by 2, it is 0, it is pi by 2, then we have pi, we have 3 pi by 2, then 2 pi. And here the angles are minus 1, 0, minus 1, and all real numbers from this minus 1 to 1. So when you put theta equal to minus pi by 2, the value will be minus 1. So minus 1 by pi by 2 is associated to minus 1. Similarly, sine 0 is equal to 0. Association will be like this. Pi by 2, sine of pi by 2 is equal to 1. Association is like this. Sine pi is equal to 0. Association is like this. Sine 3 pi by 2 is equal to minus 1. Association is like this. Sine 2 pi is equal to 0. Association is like this. That means that this arrow diagram clearly shows that this sine function is not 1, 1. Clearly it is 1, 2, because every element of this set, this codomain, will possess the pre-image in this domain. So if this sine function is not 1, 1, so how can we determine the inverse of this sine function? In this domain, the set of real numbers, sine function is not invertible. Let's have a look on the graph of this function. If you go for a horizontal line test, the line intersects the graph at 2 points, so we can say that this sine function is not 1, 1. Or in other words, let me substitute here two values for this x, x1 and x2. x1 and x2, that means I am substituting two different values for this x, and this will clearly indicate f of x1 and this indicates f of x2. That means on substituting two different values for this x, we are getting the same values for this f of x. That means f of x1 equals f of x2. So we can say that this sine function is not invertible in its domain. तो इनवर्स निकालने के लिए हम क्या करेंगे? What is the procedure to get the inverse of this sine function? We will do one thing. We will restrict the domain. We will restrict the domain of the sine function. Look here. If you consider a function f from x to y and the function is 1, 1 onto function. 1, 1 onto function. Then there exists some another function g from y to x. यहाँ पे हम लिखेंगे such that f of x equals y and the function is 1, 1 onto. If the function is 1, 1 onto, that means the function is clearly invertible function. Let us say that f is a function from x to y such that f of x equals y. Then there exists some another function g from y to x, which implies such that g of y is equal to x. In the same, I will denote this g by f inverse. That means if f is a function from x to y, that means f of x equals y. This implies that f of inverse f inverse of y is equal to x. That is, we say that f is an invertible function. In the same way, we will determine the inverse of this sine function. We will do one thing. We will restrict the domain of this sine function. Now draw another graph for the sine function. It is minus pi by 2. This is 0. It is pi by 2. And this one is pi. Draw the graph. We will do one thing. We will restrict the graph. We will restrict the domain of the sine function. We will restrict it from minus pi by 2 to pi by 2. देखिए यहां पे अगर हम ऐसा करेंगे, we will restrict the graph, the domain of this function from 0 to pi. Again, you will get this portion. When you go for horizontal line test, the line will intersect the graph at 2 points. Therefore, the function doesn't remain 1, 1. So we will do one thing. We will restrict the graph of the sine function like this. यहां तक जाएंगे हम, यहां तक जाएंगे. Go for the horizontal line test. So this line intersects the graph exactly at 1 point. So we can say that the function is 1, 1 in this interval from minus pi by 2 to pi by 2. Therefore, we can say in this domain, in this restricted interval, sine function is invertible. Look here, then we can say sine, since we have restricted the domain, so the domain of this sine function is minus closed interval minus pi by 2, and the range is minus 1 and 1. Similarly for cosine function, cos के लिए हम इस तरह से restrict करेंगे डोमेन को. We will go from, if we will draw the graph of this cosine function, it is like आपका y-axis, then we have this x-axis, minus pi by 2, 0, it is pi by 2, then we have pi, we have 3 pi by 2, another quadrant is this one, the angle is 2 pi, it is 1 and minus 1, the graph at 90 is cosine is 0, so it further decreases to minus, graph will be like this, 3 pi by 2 पर ये फिर से 0 बनेगा, and at 2 pi it is equal to 1. Similarly, यहाँ से ऐसे ग्राफ आएगा. Go for the horizontal line test. Again, the function is not 1, 1, so we will restrict the domain from 0 to pi. 0 to pi. So the restricted domain to make the cosine function invertible is 0 to pi. So cos will be like this, 0 to pi to minus 1 and 1. Right? In this domain, we can find the inverse of the sine function and cosine function. Further, we will go for tangent function and their reciprocals. So sine restricted domain is minus pi by 2 to minus 1, 1. For cos, it is 0 to pi to minus 1 and 1. In these intervals, we can say that sine and cosine functions are invertible. Now look here, as a function is invertible if it is 1, 1 and on 2. So f of x equals y implies f inverse of y equals x. Now look here, this interval, this minus pi by 2, and the closed interval 0, pi, these are known as principal branches, principal value branches for sine and cosine functions. and the values obtained in these branches in this interval and in this interval are called principal values. Now, if sin x is equal to y and this time sin is 1 1 and 1 2, so that is this sin is a bijective function, therefore we can determine its inverse definitely, and this will definitely imply that sin inverse of y is equal to x. Now let's have an example here. We need to determine the principal value for this sin inverse 1 over root 2. Let sin inverse 1 over root 2, let us say it is equal to y. So we can say that by definition of inverse of the sine function, that means sin y is equal to 1 over root 2, and you know that sin pi by 4 equals 1 over root 2. This implies that clearly if sin y equals 1 over root 2 and you know that sin of pi by 4 is equal to 1 over root 2, that means these two things are equal. Sin y equals sin of pi by 4, which implies that y is definitely equal to pi by 4. Look at this pi by 4. It belongs to this interval, definitely. The closed interval minus